So this is topic 2. In this session, we'll discuss about uh, the purity of a substance as well as the different separation techniques which we will use to separate the different substances from each other. This is a learning objective, criteria of the purity, and before starting the explanation, you should be able to identify the type of apparatus used for different quantities. Like example, if you want to measure a time, so the apparatus which we use, that is a stopwatch. If you want to measure temperature, you use thermometer. If you want to measure the mass, we use a balance. And if you want to measure the volume, we can have different apparatus. We can use a beaker, we can use a burette, we can use pipette, we can use measuring cylinder, or we can use a gas syringe. You can copy later because I'm sharing the course material after the session, so you can copy from that part. Right now, it is important that you understand the topic and able to interpret your ideas, and later you can copy from the course material which I share on the group. The term variable means the quantity which can change, that is called variable. Like example, time is variable. Time is not fixed, it can change. Temperature can change, mass can change, volume can change. That is why these terms are known as variables. So if you want to measure a time, a variable time, like example, I want to measure 30 seconds, 50 seconds, 100 seconds. So the apparatus which is suitable is stopwatch. If I want to measure the temperature, there are different types of thermometer which are used, but we use liquid in a glass thermometer in our lab. If you want to measure the mass, we can use a balance. And if you want to measure the volume, we can use beaker, burette, pipette, measuring cylinder, or a gas syringe. So these are the apparatus which can be used for measuring certain variables such as time, temperature, mass, and volume. And A is a beaker, this one is a burette, B is a burette, C is a pipette, D is a measuring cylinder, and here you can see a gas syringe. Is it clear? Now, which condition, what apparatus is suitable, that depends on what volume we are measuring. Example, normally beakers are used for approximate volume, not exact, but if you want to measure the approximate volume, we use beaker. Like example, I want to any volume it can measure, but if we don't want exact volume, we just want, like if I say I need approximately 100 cm cube or 200 cm cube of liquid, then the apparatus for measuring the volume I will use, in that case it will be a beaker. But if I want to measure the accurate volume, so the most accurate apparatus here is a burette. A burette can measure 0.1 centimeter cube accurately as possible, with the maximum volume it can measure is 50. It cannot measure more than 50, but with the exact value, the smallest value it can record, that is equals to 0.1 centimeter cube. If we want to measure a fixed volume, like example, if you want to measure exact 25 cm cube exactly, in that case we will use a pipette, because pipette is not having markings, it can only measure one volume, like 25 cm cube. If I want to measure like 24.9, then I cannot use a pipette. Why I cannot use a pipette? Because the only volume which a pipette can measure is 25 accurately as possible, not less than that, not more than that. And if we want to measure a volume approximately 100 cm cube to the maximum, and the smallest value which we want to measure is 1 cm cube. In that case, we can use a measuring cylinder. So measuring cylinders and beakers are for approximate volume, not exact. But burettes and pipettes are more accurate. They are used for exact volume. So if I say I want to measure 10.3 cm cube. So which apparatus is suitable if I want to measure 10.3 cm cube? Beaker, burette, pipette, or a measuring cylinder? Which apparatus is suitable if I want to measure 10.3 cm cube? 10.3 cm cube. A measuring cylinder can measure accurate 1 cm cube. A measuring cylinder can measure 1 cm cube, the smallest value 1, like whole number. It cannot measure points. It can be like 10, 11, 12, 13, but not 10.3. So it cannot be measuring cylinder. What about pipette? A pipette can measure accurately 25 cm cube, not more than that, not less than that. Like if I want to measure 24, 23, 24.9, I cannot use pipette. What about the beaker? Same thing for beaker. Beaker maximum, you can have different size of beaker, and beaker can be accurate to 1 cm cube as well. It cannot measure like point in decimal. The most accurate apparatus to measure zero point 0.1 cm cube is a burette. So the correct answer for measuring 10.3 cm cube is burette. So whenever like zero point 0.1 cm cube you want to measure a volume as accurately as possible, you will always prefer the most accurate apparatus, which is burette. But if you want to measure 13 cm cube approximately, which one is suitable? If I want to measure 13 cm cube approximately, which apparatus is suitable here? 13 cm cube approximately, not exactly, approximately. So which one is suitable? A beaker, a burette, a pipette, or a measuring cylinder? A beaker can measure approximate volumes accurate to 1 cm cube, and usually used for large volume of liquid. So if I want to measure a large volume of the liquid, then what we use, we normally use a beaker. For a burette, if you want to use a burette, it is used for accurate to 0 0.1 cm cube and maximum measure 50 cm cube. And if you want to use a pipette, it measures only 25 cm cube accurately. And for measuring cylinder, it is used for approximate volume, accurate to 1 cm cube, and they are usually used for small volumes. If you want to measure a small volume of the liquid, we normally use a measuring cylinder. So when I check this value 13 cm cube approximately, I don't want exactly, so it cannot be burette, it cannot be pipette. Why not burette or pipette? Because burette and pipettes are used for exact values, accurate values. So we just need an approximation. So either beaker can be an answer or measuring cylinder can be an answer. But which one we'll select? We'll select a measuring cylinder. Why we select a measuring cylinder here? Because measuring cylinder normally they're accurate to 1 cm cube and they're used for small volume. And what could be the range of small volume? It can be maximum with 100 cm cube. Even if you want to measure anything till 100 cm cube approximately, you can use a measuring cylinder. But if it is more than that, then we prefer to use a beaker. Same way, if I want to measure 25.0 cm cube, when I say 25.0, it means I want to measure exactly or accurately. So which one is the most suitable instrument here? 25.0 cm cube. So in that case, we can use a pipette. Burette can also be used, but the most accurate one will be pipette. Is it clear the condition in which we use these certain apparatus? Is it clear to everyone? Then what we call a pure substance or an impure substance, or how we call or how we know that the substance is pure or impure. So if a substance is pure, or a pure substance is a substance that has no particles of any other substance mixed with it. Like example, you have a salt, sodium chloride. So this salt, sodium chloride, it contains sodium and chlorine. So, and the salt crystals are there. So this is example a crystal of sodium chloride, which contain sodium and chloride ions. The black spots are representing the chloride and the pink spot will represent the sodium. So this salt contains sodium, and this is a sodium chloride salt, so it contains sodium and chlorine, two substances. But what will happen if I add another substance? Example, if I add another substance, I add an iron now. So I was having a salt sodium chloride, but I add another substance iron here. So what it will make it impure. So impure means, like if I say I have sodium chloride, but if that sodium chloride contain another substance as well, we will call that substance as impure. But if there was no other substance, like example, if I say I have sodium chloride, so I have only sodium and chloride only, in that case I will say that substance is a pure substance. So pure substance contain only the particle which are mentioned, like sodium chloride means there is sodium and there is chloride. But when I say impure sodium chloride or impure substance, so impure substance contain different particles other than what is present. And here also example, we have a salt, sodium chloride. So there are sodium ions and chloride ions. But it will also contain other substance, like this is sodium and chloride, this is pure right now. But what happen if there is also another substance present? Example, iron atoms are also present. Then what we call this substance, we call that substance as a impure substance. Why we call impure substance? Because it not only contains sodium and chlorine, like this one is sodium, the other ion is a chloride ion, and we have iron as well. So it is not a pure. Why it is not a pure? Because it contains iron as an impurity. And in this example, we have just only sodium ion and chloride ion. So when we have only one, like the so what is mentioned in the name, that same particles are present, we call that as pure substance. Is it clear? The difference between pure and impure substances? Example, another example, you have a container which is filled with water. So example, you have a container which is filled with water, and these are the water molecules which contain oxygen and hydrogen. Two hydrogen atoms join with oxygen. Oxygen, hydrogen, hydrogen. Now the question is this a substance is pure or impure? This substance So this substance is a pure substance because it contains identical particles. But now what I did, so this substance is a pure substance. Now what we did, we add sodium chloride, NaCl, the salt to water. So when we add this salt to water, it causes sodium ion and chloride ions. Now this water is pure water or impure water? So in this case, it became impure. Why it became impure? Because it contained other particles as well. So the water will turn into impure. So basically, if we have identical particles, same particles, we call that as a pure substance. If we have different types of particle in a substance, we call that as impure substance. Now, what is the effect of the impurity, or what are the effects of the impurity, and how to check whether a substance is pure or impure? So what we can do, we can check the substance whether it's pure or impure by different ways. We can check the melting point, we can check the boiling point, or we can use a chromatography. Chromatography we'll discuss in detail. But what about the melting point and the boiling point? So if we want to check the substance is pure or impure, what is the how we can check? We can check the melting point. This is done for solids. We can check the boiling point, or we can use a technique which is known as chromatography. So these are the techniques which we can use to identify whether a substance is pure or impure. Because what happens when a substance is impure, its melting point will decrease and the boiling point will increase. This is the effect of the impurity on a substance. Its melting point decreases and its boiling point increases. Example, say you have a pure ice. What is the melting temperature of a pure ice? What is the melting point of a pure ice? When ice is pure, at what temperature it melts? So when the ice is pure, it melts at 0 degree centigrade. That's right. But what happens if the ice is impure? Impure ice means, like example, that there are other particles as well. Example, you have ice. So this is a piece of ice which also contain impurities. These black dots are representing the impurities, the black spots. So the ice become impure. If the impure ice is there, what we will observe, it will melt at lower temperature. So example, if a pure ice is melting at 0, what is the lower than 0 or less than 0? It's like -1, -2. So it will melt at -2 or lower than that. What is the reason why the impurities lower the melting point? Because what happened, if these are the particles within the ice, they have attraction between them. Like these are the particles of ice. So there is a bond between them, or there is an attraction between them. They're connected to each other and attracted to each other. But what happens if the ice is impure? Then you can clearly see here that the number of attraction decreases. The bonds between the ice particles, there is but few attractions. So as the attraction between the ice particle decreases, what will happen? Which sample will melt at low temperature? A or B? This is a pure substance and this one is impure. So which substance will melt at low temperature? Which substance we need less energy? So in case of B, we need less energy. So the impure substance, it will melt at low temperature. And for pure substance, it will melt at high temperature. So whenever we add impurity or impurity is added, the melting point of the substance decreases. Is it clear? Why the melting point of a substance decrease as a substance becomes impure? Yes, Abdullah?
Sir, the particle in structure A is structure B. It
Mhm.
has a different melting point, so we will need more temperature to melt it.
But the number of attraction, you can see here we have more attraction between the particles, okay? But when impurities are there, impurity means there's another substance, another particle is present. So that particle will not allow the attraction, because we need energy or we need temperature to break the attraction between the particles. Here we have few attraction between the particle due to presence of impurity. Here we have more attraction between the particle due to presence of the same type of substance, or a substance is pure. So when we have to supply energy, which one we need more energy to separate the particles or break the bonds? In A, because there are more bonds, so we need more energy. In B, there are few bonds, so we need less energy. That is why it will melt at low temperature. Is it clear?
Yes, sir.
So whenever a substance is impure, the melting point will decrease. But what happened to boiling point? When a substance is impure, the boiling point increases. But what is the reason boiling point of an impure substance increases? Because boiling means when the liquid change to gas. So you want to remove all the substances, all the particles from each other. Like what happened? Not only breaking the bond, but you want the particle to escape. So example, this is a pure substance, identical particles are there. Same type of particles. If you have impure substance, example, if you have impure substance, different particle is there. Now when I supply energy, first thing I have to break the bond. That's one thing. Here I have to break more bond, here I have to break less bond. But second thing, I want to convert the liquid state into a gaseous state. So when these particles, the bonds break, they can easily go out. But what happened here, when we supply heat energy, the impurity molecules or particles does not allow these particles, because these particles, the impurities are on them, so they need more energy to move away from the impurity and go out from the substance. That is why when a substance is impure, it will boil at high temperature as compared to a substance which is pure. So example, if you have pure water, the pure water, it boils at 100. But if you have impure water, like a water contain other salts or salt solution, so at what temperature it will boil? It will boil at around 104 degrees centigrade or more than that. So impure substances boil at higher temperature as compared to pure substances. Is it clear? This idea? So impurity lower the melting point and impurity increases the boiling point. Is it clear to everyone? The effect of impurity? So basically what happened, when we are converting a liquid into gas, we supply energy, particle break the bond and they can go out. But for example, if impurity molecules are placed on the other molecule, so they need more energy to overcome or move these particles. That's why the impure substance need more energy as compared to pure substances. Here when we supply energy, these particles easily escape because they don't have other particles on them, other material. But here what happened, when the particle gain energy, they have to push these impure molecules, impurity particles, and then go out. That is why this will have a high boiling point. Is it clear to everyone, the effect of impurity? Okay, so